I'm clicking the start button. I'll let you know when we're live. We're live.
Good morning, everyone. My name is Tony Cradafil. I'm the Chief Engineer and Chief Operating Officer for the Michigan Department of Transportation. And I want to welcome you today to our very first ever Michigan State Transportation Innovation Council Highlights webinar. This is a really exciting kickoff for us here in Michigan. The State Transportation Innovation Council, or the STIC, is an organization that was started as a partnership between the Federal Highway Administration and MDOT about a decade ago, that has industry representation from all levels of government, as well as members of our heavy construction and transportation industry. And is really aimed at how we can accelerate the adoption of proven innovations into the transportation industry. In the last year, the STIC has been expanded to include representation from our elected officials in the legislature, as well as additional industry representatives from associated industries, aggregate drainage areas, and so forth. And in the last year, we also did some peer exchanges with STICs in other states to learn how they performed ways or look for ways to expand the information about innovations that are happening throughout their state. And one of the ideas was to do a webinar much like this. It is also built upon an internal MDOT practice we've been doing for the last several years of these kind of quick hit highlight presentations that just kind of whet people's appetites. You learn a little bit about something, and then if it seems practical or you want to learn more, you can follow up with the presenters to really understand more about how they went about implementing that innovation. So I encourage you, as you pay attention to today's presentations, to note those presenters, and as always, follow up with folks to learn more about what they've done. Today's session will be recorded and posted on MDOT's innovation page. We will provide a link in the Teams chat here that will get you to that page so that later on you can find that, as well as other information about the STIC. So with that, again, welcome, and I hope you enjoyed today's presentations. As practitioners in this transportation space, if you have innovations in the future, please let us know. If you are a contractor or supplier, work through your industry associations. If you are a transportation agency, you can come to MDOT or the County Road Association or Michigan Municipal League as well. But we will be doing this at least 2 times a year, and we're always looking for great ideas to be able to share with the broader transportation community. So with that, I'm going to turn it over to Brad Weifrick. He's our director of our Bureau of Development, who is going to facilitate today's session. Thank you.
Great, thanks, Tony. I appreciate that, and we're looking forward to a action-packed couple of hours here. So I'm not going to talk a lot. I'm going to get this rolling and introduce Mr. James Castle. He's the Assistant District Manager for EJ, and he's going to be talking about self-level castings.
Good morning, everybody, and happy St. Patty's Day. Started out already on the bumpy road here. Let me get my presentation pulled back up with the computer sound. And here we go. All right, back to where I was. John, don't be mad at me. I know we practiced this multiple times to make sure it went smoothly, and here I am right off the get-go. Again, good morning, everyone. Like Brad said, my name is James Castle. I'm the Assistant District Manager for EJ. Many of you know us by our former name, East Jordan Iron Works. We are one and the same. It is still the same company, still the same family that started it in 1883 is at the helm, but we have changed our name about a half dozen years ago, and we are EJ. But again, very fortunate to be known as East Jordan Iron Works as well. I want to thank everyone for the opportunity today. I want to get started by putting everybody in the correct mindset. Beautiful Michigan day, summer. You're in your car, you got the windows down, there's not a cloud in the sky, you got your favorite song on the radio, and you're driving. And all of a sudden, boom, you hit a manhole frame and cover. And in your head, you say, man, someone should do something about that. Or you're on your commute back and forth to work, and you look in the distance, you see, oh, arrow board. Oh, you see some signs. Oh, you're now in a construction zone. Come up and you look and you say, well, what are they doing? Oh, it's a crack seal job. They're working around manhole frames and covers to crack seal them. Okay, man, someone should do something about that. Okay, well, we have the product to do that. Okay, again, this is our new facility up in northern Michigan. This picture right here, this is in Elmira, and again, this is a family picture from the original foundry days. So, again, you're now in the mindset. You now have this idea where you're driving down the road and you hit a manhole frame and cover. Now, I can tell you, when it was set, it wasn't in that condition, right? It wasn't in that condition, but over time, it has moved. Okay, so for those of you that can see this here, imagine if there was a casting that moved with the pavement. As the pavement heaved, it moved with it. As the pavement settled, it settled with it. For instance, if your structure were to settle, the bottom frame would move with it. And this is the self-level casting for asphalt application. Now it's a four-part casting. You have the guide frame, the upper frame, the cover, and then there's the gasket. Okay. What this is designed to do is rest on your wearing course of asphalt and move up and down with the pavement as it flexes. Again, when the first casting was set, it was set to grade to make sure that the ride was good. But over time, the pavement has moved, but the casting hasn't. That's what causes that cracking and spidering around there, because the casting is fixed, but the pavement isn't. And it's going to move a little bit, and it's going to cause it. And you'll see those cycles as you go through the different seasons. So the whole intention is for it to move up and down with the casting. Now, 5 degrees in any direction, because you want to make sure that you match the road grade. Roads typically aren't flat. There's got to be a pitch to promote positive drainage. Okay, so another one that's really not on this list is bad subgrade. If you're building a roadway over bad subgrade, you know that, one, it's going to be expensive to do, and two, it is challenging to keep that pavement in a good condition. Now, of course, you won't have a great deal of structures in that area if you can avoid it, but again, if you're building a road over bad subgrade, that roadway and that base is more inclined to want to move a little bit than a standard good condition subgrade. Okay, so if you think about it, your pavement isn't going to last forever. This isn't going to make it last forever. But if you can get another 6 to 8 years out of your asphalt life and not have to have come in and done any remediation or any repair work, and your constituents have driven over this multiple times and never had an issue with the ride quality, then by all means it's worth it. So I know there's some popular questions that come up when we first take a look at this. At the end, I'll be happy to answer those questions. So I'm going to move along here with this video, and I hope that everyone can see it. Apologize, the narrator's not all that exciting, but I will not talk through this so that everyone can get the information included.
Install the guide frame on the manhole structure. Lower guide frame must be set 10 inches to 14 inches below finished grade. Backfill guide frame with standard road base material per your local specifications. Install upper frame, compact backfill and or base leveling lifts as specified. Pave over upper frame. Remove the asphalt from the upper frame. Lift the upper frame to 1.5 inches above the asphalt. Pack the asphalt under the flange until the upper frame remains 1.5 inches above the asphalt. Clean the cover as needed. When compacting, start with the outside perimeter, working the asphalt to the center.
Okay, so you've watched the video. There's multiple ways of what I call protecting a casting in a roadway. I'm not saying that the other ways are good or better or worse. I'm just saying that I'm providing you an alternate to protecting that casting, to getting you the desired finish that you're looking for. This gets completed with the paving process. Now, there's no delays in opening your roadway. If you have an application where you have a pretty heavy profile between your base, your leveling, and your wearing, you can come back and you can remove the pavement and have the structure being plated, come back and remove the pavement and set it in the same lifts that you would want with compaction, and then come through with the roller, or you can do it as part of this paving process. So there's no additional crack sealing required because there's not dissimilar materials. Adjustments later on are very simple and easy to do. If you're doing an overlay, this can be, it has to be manually broken out of the asphalt, but it can be reused for overlays, mills and fills. So there is no challenges presented with those down the road improvements to the roadway itself. And the nice thing too is the setting of the casting doesn't have to be perfect. Why? Well, there's 4 inches of travel. Let's say you set this casting 4/10 off. So if you're the contractor responsible for doing that, then it doesn't have to be perfect. It doesn't have to be spot on. You don't have to come back and adjust it to get it to, you know, exactly where you need it to be. It can be done as you come through and pave. So let's talk about some design aspects. I mean, design 101 is if you can put a casting in the green belt, you do it. You don't put it in the roadway. Design 102 is that you don't put a casting in a drive lane, right? In a wheel path. Those are the 2 design criteria, but we all know that that both happen. And so, as you can see in the series of pictures at the top, that casting is right in the wheel path. They've paved over it. They've removed the asphalt. The video makes it look a little bit more complex than what it really is, but you got to come back and you got to compact it. And when you compact it, the graphic showed compacting from the outside. You're not really getting lateral compaction, but you want to compact from the outside and then you roll right over it. You don't dance around it. You're not ginger with it, and it can't be a peanut roller. You have to have a full-size roller. That way you have enough weight. Now, kind of human nature that you want to place more asphalt underneath so you know that you have full coverage, but you can't have a ski ramp. So when you turn the vibratory on the roller on and run over it, it finds its equilibrium with the asphalt, and you get a nice finished surface. Okay, so I'm touting the benefits of this. I'm telling you that it works. Well, you expect me to tell you that, right? What I want to do is I want to show you. You can see in the series of pictures below, this is in Traverse City. They get some inclement weather from time to time. And in June of 2014, the self-level was installed, and you can see the sequence of pictures as you go across all the way to 2019. The one thing you notice is it looks the same in every picture. It looks the absolute same in every picture. Again, prove that it works. Well, the oldest install we have in Michigan, it was done in 2012, and it was actually done in an MDOT roadway in the city of Coldwater as part of a project. Okay, that's great. Well, every year since then, Coldwater has continued to do projects in their city, and they've mandated that these castings be used, that the self-level castings are their standard. Now, we have self-level castings installed in DOT roads all over the state, county, and local roads. But again, I'm going through this briefly. I want to make sure that I point the aspects of the casting out, but I want everyone that's watching to understand the benefits, at least as I've explained it to you. Get set with the roadway. With the roller, there is no adjust. Okay. Now, there are some items that we can go through with you, particularly if it's an existing structure. Fully compacted, the upper frame on the guide frame is about 10 inches. I never want it installed at fully compacted. The upper frame cannot be sitting because if you drive over it, it serves as a spring of sorts, and it will not function. If you do not have clearance between the roadway and the top of your cone, now if you've got brick or block sections, those can be removed. And you've seen a lot of these pictures and graphics that we have our Inforizer. That's our MDOT approved adjustment ring, and it comes in 1/2 inch to 3 inch increments or I'm sorry, 1/2 inch to 3 inch in 1/2 inch increments. And I just tell the designers, leave your, and the contractors and even the precasters when they're putting their packages together, leave your structure minus a foot. Put the desired thickness of inferizer in, set your asphalt version of the self-level casting, and work from there. Now, let's say 5 degrees, let's say you're on a steeper incline. We make tapered inferizers that go along with these. So then you can utilize the adjustment ring to make that taper up so that the casting still fits right and it's not torqued too far to one side. Okay? But compaction is key. It's not, this isn't something that's overly complex. This is actually rather simple, but we as a company will come out and help support the installation because to some folks, it's new. Sometimes new can be confusing. We are there to help instruct and guide, whether it be from the design start, you know, when you're designing a roadway, when the install is going, or even afterwards. Okay. I always preach situational awareness. These are great in roadways. If you're somewhere off the beaten path in a parking lot and you're putting one of these in, I would kind of caution you, just use a standard casting, right? The roadway castings are subjected to a lot more abuse than one that would be off the beaten path, right? Don't use this, you know, in those applications. Just use a standard casting. But again, I wanted everyone to understand a little bit about these castings and understand the benefits, at least as I've explained them to you. So I'm hoping there'll be some great questions, but I'm going to go into the next product. So we took the idea of this asphalt self-level and we went ahead and applied it to the valve box. Now, I know that valve boxes are generally a local jurisdictional requirement, whether the municipality or whoever it might be, that they'll mandate who the what valve boxes get used, but they're still in DOT roadways, county, you know, local roadways. I don't know what it is about valve boxes, but they're either buried or they've heaved up and broken off. We took a great concept with this asphalt self-level for the full size and incorporated it into our valve box tops. As you can see, the very top of that is very robust and will handle traffic back and forth just like the other one. It doesn't sit up proud, it does sit flush, and that rolled edge is designed to accept that asphalt. Okay, so that is the same concept, a very similar installation. Okay, now not all roadways are asphalt, so we have a concrete version as well. Now, a couple of things to point out about the concrete version is that the guide frame is actually on the inside and not on the outside. Well, wait a minute, if it heaves and moves up, your class 2 or your 21AA or whatever you have for your engineered fill around there will migrate underneath and prevent it from setting back down. That's what the steel ring is for around the outside. That's where you'll see it. And again, you see this one utilized with an inferizer. So the other design aspect that I like to point out to everyone, and I'm going to start this video or start the video in just a second. The 12 inches minimum concrete around there, but the handles, call them the handles because that's what everyone lifts that up proportion with. Those are your dowels, those are your anchoring points, and those are about 4 inches down. So drive approaches, roadways will always be 6 inches or more. But if you're utilizing these in a sidewalk, where you get a lot of the pedestrian traffic and you get concrete that's broken up, and a lot of times it fails right at the casting because that's, again, same concept. It's not moving, but everything around it may be, that you have to at least make that concrete 6 inches. There is no ACI code that I can find, but I want 2 inches of concrete underneath those anchoring points, underneath those handles, okay, at a minimum. So just something to consider for design for that. And then I have a video here real quickly to show you. It's only a minute-long video. It's actually an installation done at one of our facilities, and it's a lot of LTL, a lot of truck traffic. use my time up here. I want to buzz this along here. This was the Inforizer product that I was talking to you about that is very, very effective, should go with every self-level casting we have. And really, it adds to the flexibility of the overall product. And these are on the M.QPL. So I am happy to answer any questions that you might have. I hope I generated a lot of questions. Those are the best conversations that generated some of that interest. A lot of information about these products and other products, including local specifications, are on ejco.com. So feel free to browse there. If you're still a click person and you want to download any literature or brochures, we have them all available there. So I encourage you to stop in. And again, open it up for questions now. I thank you for your attention, and my contact info is there. So I'm happy to answer any questions that you might have.
Hey, thanks for that, James. Appreciate it. And I was a little remiss at the beginning. I think I assume everybody's a Teams expert by now, but we can't communicate directly with the audience here. But please do put your questions into the QA chat there, and we'll be monitoring those. There's just one in there right now, James. It says, does it work well with a concrete collar set in the HMA as well as without?
It can, but I would any concrete application would be the concrete self-level, even in a concrete collar. The concrete collar is a very well researched and applied process. I think that by utilizing the asphalt self-level, it gives you another option to having to do the concrete collar. It achieves the same results as a concrete collar would do, just different measures to get it installed. Again, I don't want to dispel the concrete collar application, but I would look that the asphalt self-level could be used in lieu of the concrete collar, or if the concrete collar was the desired application, put a concrete self-level casting in that application.
Great, thank you very much. Like I said, we'll continue to monitor the question answer, so please provide any other questions you might have. Spirit of time, I think we'll get rolling on to the next presentation. It's going to be Aaron Poyce. He's the Geotechnical Subsurface Investigations Engineer within MDOT's Bureau of Bridges and Structures in our Geotechnical section. Aaron's going to be presenting on how MDOT is improving their geotechnical subsurface investigations with the use of the cone penetration test. So take it away, Aaron.
Thanks, Brad, and good morning, everyone. Like you mentioned, I'm Aaron Poyce. I'm a geotechnical engineer in the Geotechnical Services section here at MDOT, and we're going to present a STIC highlight of how we're beginning to use cone penetration testing to improve our site characterizations. Brief overview of what we're going to talk about today. Why do we need to improve site characterizations? What is the cone penetration test? Something that's newer to some, or probably most, and looking at the MDOT's CPT equipment that we have, review a couple of projects just to kind of show examples, and then see what we're doing now and where we're going, and then some kind of initial conclusions. So improving site characterization, why do we need to do that? Why is that important? Well, up to half of the major infrastructure projects suffer impacts to schedule or cost because of geotechnical issues. And really the root of these geotechnical issues is that they weren't encountered or dealt appropriately with, in the design phase of things. So when we don't have a thorough investigation, we're going to miss some stuff, and that exposes us to risk. So as FHWA, and others have seen this, but they made a point of emphasis in Everyday Counts 5 to have advanced geotechnical methods and exploration, or their A game, as an emphasis to to really bring forward some underutilized methods that would help with this improvement of site characterization. And the idea behind the A game is to reduce risk by reducing uncertainties in our site, improving the quality, so we can, the quality of our investigation, so that improves the confidence we have. We can maybe avoid some unnecessary conservatism, and then it accelerates project delivery. A well-scoped investigation provides timely information to make decisions, during the design and construction process. I think this is a good graphic. This actually comes from an NCHRP synthesis of 484, and really just trying to show here that this is the cost of site investigation as % of contract award on the x-axis, and then the total increase in construction cost on the y. And really what it's trying to show is, with minimal site investigation, you're exposing your project to large risks. And this isn't to spend dollars for dollars' sake, but the point is, if we do a more thorough or complete investigation, we're reducing that project risk to overruns and time delays and stuff like that. So to the CPT, what is it? Well, the CPT, or cone penetration test, is a cone, or it's an instrumented probe, as you can see on the right. It's got, we measure several things. It's a tip. We can measure the tip force as we insert this into the ground. It measures the sleeve stress. That's this kind of bottom cylinder here. So as the cone slides through the soil, picks up the frictional resistance there. The white disc here is a filter for picking up pore pressures in the ground. So we can see what those look like as we go forward. And then this one has a geophone, or you can do some seismic testing with it too. We'll talk a bit more about that. But this gets pushed into the ground, constant rate of advancement of 2 centimeters per second per EASTM standards. And then you take a reading of all of these parameters every 2 centimeters, so every second. So you're getting just a tremendous amount of data, much more than our standard penetration tests, where we take 18-inch samples every 5 feet. So there's a lot of the soil that we're not seeing. A little bit about the history. CPT is not new. It's debuted in 1932 in the Netherlands with a Dutch cone. It's a mechanical device pushed by hand. World War II brought the advent of some electric cones, and today it's used extensively in Europe and Asia. It's picking up here in the US and North America probably since 2000, with early adapters being those areas kind of in a seismic zone where the shear wave velocity of the soils are really important, and we can measure that with CPT. Pictures on the bottom left, these are some rigs from that MnDOT, Minnesota DOT has, a couple of trucks, and then an ATV. The one on the right, that's ours, a much smaller scaled down version, but a much lower entry price point to entry. The CPT is really the blue frame that's sitting on the Bobcat. That's the nuts and bolts of it. Just a brief video to show, the penetration. So this is our, going in at 2 centimeters a second. The operator's watching the screen, making sure we're staying in there, that our inclination's good, also watching the results in real time. You can see the cable that runs down to the cone through the rods. Anyway. And then this is just another short clip here. Again, you can see the penetration occurring, and then you can see, in real time we're getting updates, the tip resistance, the sleeve resistance, the pore pressure. The graphic on the right is soil behavior type, which is something we'll talk about here, which is a little different. Okay, so he mentioned soil behavior type is not a soil classification. So we're not pulling samples out of the ground. We're not saying this material is silty fine sand or sandy clay. But what we do get out of the CPT is there's been relationships set up. And again, these are correlations. But how is the material behaving? Is it behaving like a silty sand, or is it behaving like a stiff clay? You know, that's what we're going to get out of the CPT. And in general, to help look at the data and understand it, there's some general correlations and relationships. You know, granular soils are going to have high tip resistance and high sleeve friction, which gives you a low friction ratio, which is the sleeve resistance divided by the tip. Cohesive soils have a low tip resistance and high sleeve friction with a high friction ratio, and organic soils have very low tip resistance, very low sleeve friction, and a very high friction ratio. This is a plot. So this is the output from a CPT. Completed this one earlier this month, and what you can see, I'll turn my pointer on here. So again, this is our tip resistance, our sleeve stress, friction ratio, pore pressure. So again, these 1, 2, 3 are the parameters we're reading in real time. And then this is kind of this soil behavior type. And you can see here down to about 32 feet, you know, very low tip resistance, some sleeve stress, but actually higher friction ratios, you know, indicating, you know, we've got some organic soils here, and we did a companion boring at this location, and yes, that's what we have. This is, you know, organics, mucks, and peats and stuff like that. And below 32 feet, you can see the tip resistance increases dramatically. We do increase our sleeve stress, but notice the friction ratio continues to decrease. So this is indicative of sands. And again, that's what our boring showed. And then I guess this is the other thing, our pore pressure sensor. This blue line is the hydrostatic pressure line, and you can see that when we're in these granular soils, that's matching up nicely too. That's another indication. This is the soil behavior type chart, and it's again the normalized tip resistance and normalized friction. You got some different zones, so sandy zones, sands and gravels up here, silts and clays down here, with some organic soils and sensitive fine grained soils here. So this yellow dots are basically the output from that previous slide I showed. So you can see that we have some organic soils and, you know, marginal organic and clayey soils there. Or the behavior is out. I'm not, again, not saying that's not a classification. The big difference there. So what are some benefits of CPT? You know, increased production rates. It's faster than drilling. We've seen with our rig and jobs that we've used that it's 2 to 4 times faster than our traditional methods. You get that nearly continuous soil profile versus the SPT sampling. Results are highly repeatable. We get some direct measurements of penetration, resistance. There's a lot of correlated parameters to strength and stiffness and unit weight and some of those other things that are important. And then there's also some you know, safety things here too. The equipment's lighter. You're just using rods, not heavy augers. Smaller crew. We actually started doing CPT about a year ago when we're right in COVID, and that worked better for our crew sizes and isolation and stuff. And then increased safety. We don't have rotational, you know, we don't have rotating parts like we do on a drill rig for, you know, entrapment and stuff like that. So it's a safer process. And the data is electronic, so it's easy to, you can send it from the field right away, no data entry. That's pretty great. Limitations, if you get into rocks, cobbles, boulders, it's not gonna, we're not gonna penetrate that with the cone. And for our setup, once you get to, you know, very stiff or hard clays and dense sands, you're kind of the limit of the capabilities. You don't get any samples, so if you need samples for the lab, you have to get those a different way. And just the startup, the cost and kind of technical operations, it's much different than, you know, traditional drilling that they're used to, and so that can be a bit of a hurdle too. So here's our equipment. We've got a Vertex system, so it's made in America, in Vermont. Again, the system, the blue frame. You can see the anchors, it's self-anchoring, so the anchors have to be seated in and secured to provide the reaction to push. Which is a problem if you have loose superficial soils. But 20 tons of push force, it's self-anchoring, skid steer, provides the hydraulics. we produced or purchased ours with the use of some STIC funds, which offset a lot of the cost of the unit itself, which was great. We started using this, like I said, about a year ago, just kind of as we were getting into COVID. Here are some locations that we've used this around the state. The red ones have completed. The yellow ones are some proposed ones. We've got about 12 locations around the state, and we've got 50 soundings, just looking at a variety of geologic conditions and and geographic locations too. Just a couple highlights here. M66 over Monroe Creek. This was a culvert replacement. This is in northwest Michigan. Like I said, we did this about a year ago, and we actually did the CPTs first because of COVID and crew sizes and stuff. And what we saw, we identified a soft zone, so that when we went back with our SPT rig, we grabbed additional samples to really investigate that, found some organic soils, and actually ended up changing the culvert type and construction methods just to make the best the best project that we could, given those poor soil conditions. Just briefly, I know this is small, but this is our soil boring that we did. Again, notice, increments versus continuous, and the red rectangles are kind of the same depths, and again, softer soils, lower resistance. Anyway, and then again, this was all 4 of them that we did. We plotted, again, a bunch of this soft organic material under the culvert. Briefly here, this is Vista Avenue over Canoe Stream. This is on Belle Isle, so it's in the Detroit River. This is a single span bridge replacement. It's we've got deep lacustrine clays, which are a little bit stiffer on top because they're desiccated, but then get soft, and 100 feet or so to some denser materials. So we did some 4 CPTs after a couple of traditional borings, and on this site we were 3 to 4 times faster. The CPT was 3 to 4 times faster than our SPT borings, which was great. So it gave us a lot more coverage. Oops. Again here, our traditional boring, this is only a part of it because there were 130 feet deep. We were able to, but again, this top area on this is of interest because we have some stiffer soils that, get softer with depth. And again, it's a little hard to see with blow counts, but we can certainly see that with our CPT, the reduction in sleeve stress and tip stress about 20 feet. That's about the limit of it. And then you can see it's very soft till we're 95 feet down. This is just kind of a summary. This is the shear strength correlation. So this isn't measured shear strength by the cone, but a good correlation from all 4 soundings. And then the red dots are actual laboratory testing. So we have a great agreement, and it really helps us define where the crust is and where we can kind of hold up our structure in it. So this additional data that we had really gave us confidence in our site, and it's allowing us to move forward with a larger box culvert here instead of having to put a bridge back and drive piles to 100 feet. So saving thousands and thousands and thousands of dollars in time for this project. So what are we doing now? We're continuing to look at our side-by-side tests with our CPT and regular SPT and some of our lab boring, just to get our head around that. Really trying to figure out this soil behavior type, where our soils plot on these charts, just to understand them and identify them better. And then looking at some direct designs with, taking the CPT data right into a spread footing design, for instance. Also looking at some soil properties to just, again, see how the correlations compare to our lab testing in our soils. What's next? We still have to figure out how to incorporate the CPT into our project deliverables and get people used to seeing them. And then we got some more evaluation of other stiffness and strength correlations, some seismic data, which gives us shear wave velocity, which that's what this is a picture of. And then we have some upcoming training, pending COVID restrictions, to do some internal training with MDOT, and then really rolling out into like a technology transfer with, multiple agencies to just share our experience and where we think it's can be used. That training is going to be funded again in part with some STIC funds, so we appreciate those. Kind of our initial conclusions, as we're still learning a lot, and we don't have this all wrapped up, but at least what we've seen so far, the equipment and the software has improved a lot in the last years, and it's pretty straightforward and easy to use, even with remote training from the manufacturer. We do see an improved stratigraphy or soil layering, really understand that, higher production rates. For us, the anchor pullout limits our pushing resistance. But that's, we kind of knew that. And then spread footing analysis, that looks good, but we won't be able to use CPT for piles more than likely, because in our geologies we're driving, into and through hard things that we can't penetrate with a cone. I guess with that, a little over, but I'll open it up to any questions.
Well, thanks, Aaron. Appreciate it. There is a question in there that says, and you might have answered it in your conclusions, is the goal to replace all borings with CPT?
I don't see that happening. What we've seen with other states that are further along, Minnesota, California, they probably have switched and pushed more CPT than do traditional borings, but I think a lot of they're using it as part of their package, and because it's faster and they'll get more data, they push more of that, but still supplement it with traditional borings. And like I said, and what they do too, you can do the CPT first, and then if there's some areas that look questionable or concerning, then those are areas that are really easy to target with your other SPT or traditional drilling methods to get samples and bring them back to the lab if you need to, or those kinds of things. Mm-hmm.
All right. Thank you very much, Aaron. Appreciate it. And we'll continue to monitor the Q&A chat as we move along. So moving right along, we have a pair of presenters coming up next. Chad Skaraki, who's the Assistant Bridge Engineer for MDOT's North Region. He's also the project manager for a research project titled Unmanned Surface Vessels for Bridge Scour Monitoring. Along with Chad, we have Kevin Longley, who's the Media Relations Manager for the American Society of Civil Engineers out of the ASCE's the Government Relations Office in Washington, D.C. These folks are going to talk about EMILY, which is our emergency integrated lanyard boat. So take it away, guys.
Thanks, Brad. I will just give a brief overview of ASCE's Gamechangers program, and then I'll pass it along to Chad, who can go into more of the details about EMILY and all the great work that it's been doing. So at ASCE, in the Government Relations Office, we focus a lot on advocacy, and one of our top advocacy tools is our infrastructure report card, which we put out once every 4 years. On March 3rd, we just released the newest addition to the infrastructure report card with our 2021 report, and gave the nation's infrastructure a cumulative grade of C-, which is the first time in over 20 years that the nation's infrastructure hasn't had a grade that was in the D range, so that's positive news. Now this looks over 17 categories of infrastructure. We added a new one this year, including stormwater. And so 5 of the categories had gone up, only 1 had gone down, which was bridges, but 5 had gone up, and that just barely got us over into the C- range. But there's still a lot of negative news when it comes to the condition of America's infrastructure. 11 of the 17 categories we assessed had grades in the D range, and we're still waiting on a major infrastructure investment at the federal level and help for all agencies across the country, and this is especially amplified by everything that's been going on with COVID, which has taken a hit to funding at the state, local, and federal level. So oftentimes this news can be a little bit of a downer to people, some of the conditions of our infrastructure, And we want people to know that it's not all bad. There's actually a lot of great work being done, and that these problems aren't going to be solved entirely just by throwing as much money as possible at things. We need to come up with innovative solutions. We need to come up with innovative practices and technologies and different ways in which not only can we drive the cost down, but we can make our systems run more efficiently and allow for safer structures all across the nation. Chad, if you want to hit the next slide, thank you very much. So with that, ASCE started a program a few years ago highlighting our infrastructure game changers. So if you ever want to highlight them on social media, we do the hashtag Gamechangers to keep them all connected. And these are all projects that highlight innovation in the field, collaboration, resilience, a number of different things. They're not limited necessarily just to innovative technologies, although that is something that does get highlighted. But sometimes there are collaborative efforts between agencies or different firms and public-private partnerships that are particularly groundbreaking, that's paved the way for new construction across the country to be done more efficiently and to get more projects out of the way and to make the public safer. And so we want to highlight those as well. We also highlight innovative programs. I know we have one game changer this year in Massachusetts as they unveiled the very first clean peak energy standard to try and promote renewable use throughout the state. And so like a standard like that, we would consider a game changer as well. And so we want these projects to improve efficiency, to possibly save money, and to improve resilience, which is especially prudent now with everything going on in regards to severe weather events. Last year alone, we saw $22 billion severe climate-related events, and so we need structures that are handling all this. And so MDOT's use of EMILY, which is an autonomous boat, and I won't get too into the specifications because I know Chad can break it down a lot better than me, but it helps promote or it helps inspect bridge scour through an unmanned boat. And this is particularly helpful and definitely jumped out to us as a game changer because this is something that can save people a lot of time. It can help improve conditions by knowing the best possible assessment of these structures. And so this is something that really hits all the boxes for us. This is actually the second game changer we've assigned to MDOT. We had one in 2017 for managing construction projects through electronics that actually ended up saving MDOT millions, supposedly. I wasn't here at the time, but I was told that was a great project and one of the first ones that we had highlighted. There's actually also been 6 game changers that have been assigned to the state of Michigan, and there are a few states that have yet to have a game changer. So Michigan's doing well on the innovation side of things, but just wanted to promote your work and get it out there and show people what is possible and how we can continue to progress the civil engineering field and save everyone time, money, and promote safety as well. So with that, I'll pass it over to Chad. I guess my dogs are now kicking me off the call, but I'll pass it over to Chad and let him explain more about what EMILY really is.
Yeah, thanks, Kevin. I think I can speak for, at least I know for myself, but probably for all of M.2 that we're really honored to be, receive the designation as a ASCE game changer. So once again, thank you for that. But for my presentation here, I'm just going to basically kind of go through kind of the research that we did, a little bit of history behind it, and then actually what we were using the actual sonar EMILY for today. And so if you got any questions, I'll probably run through this pretty quick. So feel free to reach out to me, give me a call or shoot me an email. And I enjoy talking about this stuff, so feel free to reach out. But I always like to start out, with the why. Like, why do we need a boat like this? And so I always start out with, scour is one of the leading causes for bridge failures, at least in the nation, and probably worldwide too. And here in Michigan, we have multiple scour critical bridges And so a scour critical bridge is basically a bridge that has the potential to become unstable due to scour during a significant flood event. And this can be either calculated or observed scour by an inspector. So for these bridges, we're required to go out and actually monitor the condition of them during, a significant flood event, or what us people in the bridge world usually call it like a high flow event. And in the past, it's always, we go out and we monitor these, and all the stuff that would cause a bridge to become unstable is occurring below the water line. And usually the water on these rivers, almost looks like chocolate milk. So you can't really, and they're flowing really fast. So it's really hard to determine, what's going on below that water line. So that's what kind of started the need. And also we want to keep our inspectors, in a safe position where they didn't have to get, reaching over the side of the bridge or getting down into the water or anything like that. So that's why this kind of research project was actually needed. So for the research itself, MDOT consulted AIRS Associates to kind of do the research. During the research, we looked at several different hull types, like a catamaran style, which you can kind of see up in the upper right-hand corner. We looked at monohulls, which is basically just like a regular boat. We looked at tethered units and untethered units. We also looked at stationary scanning sonars. We also looked at different types of sonar systems, whether it be like a multi-beam, which is basically like sending out several sound waves and then recording the topography of either the channel bottom or the lake bottom, or a single beam, which is basically a single sound wave. It bounces back, it gives you basically a depth. A lot of these were all the platforms we looked at were really more tailored to like survey type situations, where we wanted to put this into a river that's basically raging. So for bathymetric surveys, it's usually, you want to go slow and steady and, have calm conditions so you get the best data. Where we're trying to put this platform into, around piers, and it could be debris in the water and, water that's moving, pretty fast. So that was kind of the challenge that we had, was finding a platform that kind of checked all the boxes for our situation. And right at the end of the research project, we finally came across basically a USV that actually worked for our situation. And it was called the Sonar EMILY. It's a safe system. It's got a jet drive on the bottom, so it's basically like a jet ski, remote control jet ski. And it's robust. So it was actually, it's kind of interesting because it was actually originally developed for lifeguards to use to rescue like drowning victims or people that might be stuck in a rip current or something. But then they kind of tailored a new platform to include basically a high-end fish finder on it. And so that's what basically the two merging together kind of made the Sonar EMILY. And then we customized it a little bit by putting a few extra things on it. But here's kind of a video showing what it looks like in actual, like a flood type scenario. So like I said before, a lot of the vessels we looked at, they had a hard time keeping up in currents like this, where that's the prime location that we want to utilize this type of equipment. And this is just some of the sonar imagery that we've collected. So let me go back a slide actually. So to kind of explain what everything is. So basically the boat itself has the transducer on it, and that's got obviously all the propulsion. That's what goes in the water. But it also comes with this base station, which is basically like a 12-inch. it's a 12-inch Hummingbird fish finder is what it is, but it's a really, you know, a little bit higher end than your normal fisherman would have. But so the transducer on the boat has attached to an antenna that relays it back to another antenna that's on the base station. And then so all the stuff that the boat is collecting gets relayed and displayed on shore at the base station. And we also purchased 4 of these through the research project. And that was to kind of strategically locate them throughout the state, because as you know, you could have a flood or a big rainstorm event that could cover half the state. So having multiple units was really key for us. This is just some of the imagery that we were able to collect. So once the boat relays it back to the base station, it shows up, and it's basically just like your computer. You can actually take like a screenshot of the imagery, and it saves it to an SD card. And the nice part is you can take that SD card and put it in your computer, and you can overlay it onto whether it be as-built drawings to kind of see how the cross sections may have changed, or an underwater inspection that maybe had scour identified previously, and you can kind of track how that scour may have changed, or maybe the footings got covered up again. So it's nice to use to kind of track. And this is all what they call like down scan imagery. So the imagery that comes out basically makes like an elevation view of the pier or whatever you're trying to scan. And it's also equipped with side scan imagery. So side scan is basically makes like a plan view of the stream bed. And this is just one that the inspector identified some possible footing exposure, but we want to go out there and actually get the limits of it. And so this is the actual raw data that came from the EMILY. And as you can see, you know, a lot of people always ask me, well, you know, your abutment should be straight, right? So this is the south abutment, this is the north abutment. But one thing to remember with this imagery, it's all relative to where the boat is positioned. So the more you turn or the more you kind of maneuver left and right, the more your images will get skewed. So keeping a straight line makes the imagery a lot easier to decipher, and then you can get a lot better quality imagery. But the things that we look for is, so the bold line on the right, the furthest to the right, that'd be like your abutment wall. And then anytime you find like another line that's kind of paralleling it, you know, that would be an indication that maybe a footing's exposed, and then you can kind of investigate a little bit further once you get that. But as you can see here, it kind of had those 2 pair of lines that identified the exposure. But throughout the research, we never really had a time that we could really test it out during a real major flood. But this past year, May of last year, in Bay Region, they had a pretty good, a very significant storm event, and it really put the EMILY to the test. We were able to deploy it. As you can see from the hydrograph, at this particular location, the river basically crested 2 foot above the previous record. And these 2 pictures on the left is kind of like a before and then an after. And we were able to actually run a scan through there and identify a footing exposure that wasn't there previously. So it actually helped us to, you know, determine. I think this bridge was actually closed when we got there, just based on the raw intensity of the storm. But this kind of verified what we anticipated seeing. But once again, you can kind of see the hard line and then another line paralleling it, which would indicate the footing exposure. So, you know, that was what we kind of made or did the research for, is to get something for that situation. But what we've been finding out is a lot of our inspectors here at MDOT have been using it for a lot of other things that probably more so than we are using it for a flood event. So getting a lot of additional benefit from it. You know, some of the things we use it for is supplementing routine or doing other special inspections that might be related to scour. We have a consultant here in Michigan, an underwater inspection consultant, and they actually purchased a boat too, and they use it as like a pre-dive to identify any, safety hazards that might be hidden below the waterline before they actually jump in the water. We've also used it for culvert inspections or bridge inspections that have very limited freeboard, or basically room between the bottom of the bridge or culvert and the waterline. So we can send this through with the camera that we can see in the upper right hand corner here. It's called a RILO camera. It's a 360-degree camera, and I got a video coming up that'll kind of show what the capabilities of that are. So that's a pretty neat thing. But we also use it for like post-construction inspections. For any time we install scour countermeasures, we can go in there and actually verify the limits and verify the elevations that they put it to. So it's very useful in that aspect too. And here's just a video of the RILO camera being put to use. So what it is it's almost the size of a GoPro, but it's got 2 fisheye lenses on each side, and it records everything from 360 degrees everywhere around you. And then you can take the SD card out or upload the videos to like an iPad or a smart device, and you can actually move the video wherever you want to look. So this is nice because when you run it through a culvert, you don't have to really worry about which way the boat is actually positioned. As long as you get it, from one end to the other, you can turn the camera on the app afterwards and kind of zoom in and edit the video to look at whatever you want to look at. As with anything, there's always limitations. So as far as driving this boat, it's almost like a mixture of a remote control car and driving a jet ski. So kind of smash those two together, and that's kind of what you're dealing with to try to maneuver these things. But anytime you have large debris in the channel too, obviously you can't really run the EMILY through that. It'll get tangled up in there. That's kind of what this picture is. I don't know if you can see in the background, but there's a big log jam, and then we actually got the boat hung up in the logs. Luckily, we were able to get it out, but so that's one limitation. And like I said, it can be a little bit tricky to get used to kind of operating the boat. And another limitation is you always have to have line of sight to the actual EMILY itself. So, but with that, I'm sorry I ran a little bit over on time, but if you have any questions, I can open up for that. If not, you can reach out to me at the contact below.
Great, thanks a lot, Chad. This is excellent example of how we're using technology to make much smarter decisions. So I don't see any question. Oh, wait a minute. There is. Here's one. All right. One question is about why are they unmanned boats and exclusive of women from piloting them? I'm not sure that was necessarily the intent, but this is National Women's Month, I do believe, too. So maybe an appropriate comment there.
Yeah, I mean, I guess that's just the way it's always been called out. But yeah, there's no reason. Yeah, we have women that have used it before, so they're yeah. I guess we should be rephrasing it to unmanned and unwomaned boats.
There you go. All right, one more quick question. Have there been any situations where you were unable to use EMILY to see, in quotes, the potential scour?
Yeah, so as the one slide I had on there, it's once you get too many eddies, or if the conditions get too if it's moving around, you can't keep a straight line. The imagery can kind of get skewed a little bit and can cause some issues kind of viewing it. The other issue that we have a lot of times in these flood events is maintaining that line of sight with the actual EMILY. So in those situations, we'll usually might close the bridge as a precaution and then follow up with once the water subsides a little bit and you're able to get into a good position. And it actually helps to open up a bridge a little bit earlier too. You don't have to wait until a diver can get out there.
Great. There are a couple more questions coming in, Chad, but I think I'm going to leave those in the Q&A. If you could respond to those there. In the spirit of time, I want to make sure that we're respecting everybody's time, and we're going to move on to the next presentation. So thanks, Chad, and thanks, Kevin, for being with us. Our next presentation will be about soft binder fiber reinforced micro surfacing, and we're happy to have Monica Ackerson with us, who is the Executive Vice President for the Michigan Road Preservation Association. So Monica, take it away.
Thank you, Brad. Over the past few years, MRPA members have been testing two different processes. There's a softer binder microsurfacing and also standard microsurfacing with the Forta fibers added. And in the process, they've determined that the best results are actually coming from a combination of both, which is something I believe unique to what we're doing here in Michigan. We've been working with MDOT's Capital Preventative Maintenance Engineer, Rob Green, to have this new softer binder fiber reinforced microsurfacing specification added to the emerging technology list. I'm going to turn things over to Pierre Peltier. Pierre's going to share his screen with us. He's the Technical Sales and Business Development Manager for Strauser Construction and Terry Asphalt. And Pierre's going to walk us through the testing process and what we've learned along the way, and answer some of those very specific questions related to the specifications that people may have. Pierre?
Okay, thanks, Monica. I don't think I have it shared properly, so let me check this real quick and see if I can adjust this.
You are shared correctly, Pierre. Just start your
okay.
Yep, just start your PowerPoint and you should be all set.
Good deal. So
you still need to start your
yep.
PowerPoint.
We are.
There you go. Perfect.
We're good to go. Okay. Thanks, Monica, for that. And thanks, everybody, for allowing us the opportunity to come in and basically give you some information on what we feel is going to be something of a game changer for preservation and microsurfacing in the Michigan market area. So, I mean, why are we here today to talk about the soft binder fiber micro? Well, industry has invested its innovation dollars to its development simply because over the past few years through MRPA and the Michigan DOT, I mean, the Michigan DOT has expressed some concerns about the early reflective cracking coming through standard microsurfacing, and especially in the UP area. So this is due to, of course, the hardness of the material in the cold winter months. And some feel this leads to possible moisture intrusion into the pavements, which we all know is not a good thing. So, so we started looking at, okay, what are some of the causes of this? And we knew that Minnesota DOT was looking at and using some soft binder microsurfacing and have been for a number of years. Some of the things that always prevented us from doing that was the fear that their aggregate sources, which were very, very good granite aggregates, wouldn't quite correlate to the aggregate sources that we typically use in this part of the country, which are mainly harder limestones. So, but when we started looking at it, we started looking at, okay, the standard PG grade asphalt that we start with for producing the microsurfacing emulsion is a 64-22. And once it's developed and made into the liquid emulsion with the polymers and everything that goes in it, we're typically looking at a pin range of around 50 to 55, somewhere in there. And we knew that was kind of hard, and in the southern parts of the country, it works very well. It's been placed on the NCAT test track. It's been placed as cape seals, which is over a chip seal. It's been placed in many different situations and it's worked very well. But when we get in the northern climates, we do have some issues with the cracking. So what we did was we started looking at a PG grade of 52-28, which is what Minnesota actually uses. But they use straight 52-28 with their aggregates and everything. And we couldn't use just the plain 58-28 material. It would lower the pin to probably 100, which is almost double what we had out of the 64. But we needed something that was flexible, but yet added strength at the same time. And when we talk about strength and flexibility with the microsurfacing, we're not talking about structural strength. We're really talking about, okay, how can we create the material to stay stiffer, hold the aggregate better, and do those things, but still remain flexible. So with that, we started working with the softer binder, and we worked with the Florida group and some others that were developing basically fiberglass binder or fiberglass different fibers that we could use in the machines. And we needed something that would be dispersed evenly and not something that would ball up. We tried some polyester fibers and they would ball up in the machine, wouldn't get dispersed properly through the mix, but the fiberglass fibers seemed to work very well. So we set out to develop that, and what we found was the strength that we were looking for actually helped us, because now on those pavements we're getting less aggregate loss from snowplow damage. The fibers that are in there, even though they're only a 1/4 inch long, are helping hold that matrix together a lot better. And the flexibility we're finding is, even though you may see some minor, what I call top-down cracking in the winter months and whatnot, in the summertime, it's hard to find a lot of those. Now, I'd be lying to you if I said we could fix, full depth reflective cracking. There's nothing on the market today that can do that, and we're not going to do that either. These systems are pretty thin, so they go down at probably a 3/8 to a 1/2 inch most of the time in a single lift. So you can go about it from there, but it is just like regular microsurfacing. And it's a quick traffic, so typically by specification you can get rolling traffic back on the system within 1 hour. So, and it's very hard, very durable, very skid resistant surface. So there's a safety aspect to microsurfacing as well as we go into that. Now, I mean, the system can do a lot of different things, but when we're talking about soft binder, flexible micro, we're not talking about something that we would use in a residential type area. It's mainly going to be for county roads and highways and things like that. Basic straight running traffic in a normal sense. We're going to talk about a couple of things. A project that was done back in, I'd say, late September of 2019, and I put together just a job mix formula here out off of a design for, and this is a typical limestone aggregate with the 64-22, and the even with the fibers or without the fibers, the mix design is requiring somewhere around 11.5 to 12% asphalt emulsion. And what we found when we were doing the testing for the soft binder is that mix design wise, there really was no difference. We still had to add the same amount of liquid asphalt emulsion. We still had the same parameters that we followed. The only difference was some of the lateral displacement tests that we do in-house showed up to where they were a little different, and we had to work on that within specifications. I'm going to show a short video of the process actually going down so you can see exactly what is going on. There is no sound, but I will explain a few things as the video is going on. This was a county road that we did. We actually left about 900 feet on the east end and about 900 feet on the west end of the project without a chip seal. The county came in and actually wanted to chip seal the roadway, so they chip sealed those areas except for those. We had 3 control sections that we had in there, and one that was an in-town section that had previously been overlaid. So, but here's a typical M1 microsurfacing paver laying the soft binder fiber micro. You'll see how the fibers are injected into the, you can see right here, the fiber feeder, and it putting the fibers into, the fibers are actually dropped onto the aggregate, you can see there, and then mixed in the pug mill with everything else, the aggregate, the water, the emulsified asphalt, and any additives that are added, and then applied to the roadway surface. This was actually a double lift microsurfacing of a total of 30 pounds per square yard. Like I said, we went in and we monitored those sections. We did some crack mapping before, during, and after the placement, and I'll show those results that we have currently here in just a minute. But this is a video of the same, basically the same section you saw earlier that after the process was done. So this is that first section that we saw in the video that showed all the cracks, and this is the cracks of the 100-foot section that we actually are monitoring, and we'll continue to monitor this for 5 years. But we basically monitored, this was done and data was collected in August of 2019. You can see here, this was data that was collected in July of 2020. So we've shown a significant reduction in those cracks coming back through. I was just over the roadway a couple of days ago again, and I wanted to get a look in winter and see how it looks. There's relatively no snowplow damage to it. There are some cracks showing through, a little more than this here, but I'm almost convinced now, based off of what we've seen, that come this summer, when that pavement heats up again, those little hairline cracks that you see will probably not be visible at that point in time. Here's another section that we looked at, and these did not have any chip seal underneath them. They were just a double lift micro, and you can see that the cracking that was there before the pavement was covered with the microsurfacing. Here's in that July when we went out and collected the data for that. And then the last section, which was on the other end of the roadway, was really cracked up pretty bad. And the pavement was, according to the county, was really structurally sound. It was just old and dry. And they just wanted to save it for a number of years. And after seeing the results, they're convinced that it'll probably last longer than they anticipated. Here's that in July. Now we'll do crack mapping again in April, and then we'll do it again in July or August and see what those results come out as well. But we're really trying to address a couple of issues, and one was Michigan DOT's concerns about microsurfacing. Microsurfacing's been around the country for probably at least since the early 1980s, when I was part of a group that brought it to the US from Germany. And so it's had a lot of success and it does a lot of things. But the concerns that Michigan brought really made us stop and think, okay, how are we going to correct these issues up in the UP and in other areas? We find a lot of uses for it, not just on the roadways. I mean, I think we'll try and find some 3-foot center line, because with the soft binder fiber micro, we think we're going to be able, it is a semi-liquid material when it's placed on the roadway, and then it goes to a basically real quick cold mix state afterwards, and we think we're going to be able to feel those depressions in the center line, seal that roadway. We've done some in other states that have really held up well to try and extend the life of those roadways, where the rest of the pavement looks pretty good on the roadway. It's just the center line is deteriorating, and this may be a way for Michigan DOT to extend the life of that as well. Now, when we talk about the preservation dollars and what we're doing, and we know money's tight everywhere in the country. Hopefully we'll get an infrastructure bill that'll help out some, but we know they're tight. And this is something that Michigan State, you know, the National Center for Pavement Preservation put together a number of years ago. And they basically start out and say, you know, if you spend, you know, 16% of your budgeted dollars, you're going to complete 6% of the miles that you want to complete. You know, and resurfacing 59% of the budget dollars, and you know, you're going to complete 30% of the miles. But if you add surface treatments in there and you dedicate funding for surface treatments and patching, and this is CPM type work and what we call preservation, you know, 18% of your dollars can cover 58% of miles. So, I mean, you look at that, and we all got in years ago because we had to into worst first, and we spent all our dollars fixing these roadways that were worse, but yet the roadways that were in good condition were falling a little bit behind. So this preservation mindset really sets forth a commitment to make sure we take care of those roadways in good condition by spending just a small percentage of our total dollars to keep those, and hopefully move that scale up to where now we don't have 30% bad roads. You know, we're looking at now trying to even that out to where maybe we have 5 or 10% bad in the bad category, and maybe more to 60 to 70 in the good category, and then some in the great category. So, you know, that's kind of where this goes. We'd really love to see, you know, this done, and Michigan does a great job of following these. Rob Green and Andy Bennett have been great to work with MRPA and the groups in the industry to develop a specification for the soft binder fiber micro. I think Rob is talking about getting it done and submitted for an SP designation, and also to emerging technologies, so there can be some funding to get some stuff down there. But industry isn't really waiting on that. We've got several projects with different counties and areas that we're going to try and do some soft binder fiber micro in the state yet this season. And we'll try to set up control sections and monitor those as well. So with that, I mean, we as industry, of course, are planning several projects, and we'll make sure we get those done throughout the state this year. And you know, we feel the process will help alleviate some of the concerns that Michigan DOT has had with microservicing in the past. We appreciate the cooperativeness of Michigan DOT. They didn't say, hey, this stuff's cracking and we're not going to use microservicing anymore. What they said was, we see some issues. How do we work together to make them better and resolve the issues? Now, we're not saying that this is going to be like Swiffer was to a broom. You know, it might be as good as regular bread to sliced bread, but not quite like the Swiffer to a broom. But we feel it is going to help and take care of those concerns and help preserve Michigan's roadways much longer. Questions?
Excellent.
I want to thank Monica
Excellent.
and everybody for letting us, you know, present, of course. And I am part of MRPA. I am on the board of directors of MRPA. It's been a great group, and Michigan has really stepped forward with the group, and we have a lot of good conversations going back and forth.
Excellent. That was a great presentation, and really echo your comments about capital preventive maintenance, and it's an integral part of our asset management program so that we can most efficiently take care of our pavements. And having this tool in the toolbox obviously is going to help us even more with that. There's a couple of questions in here that we can try to cover quickly. One says, can it be placed over previously crack sealed pavements? And does crack sealing need to be done first?
And a great question. And yes, it can be. And really, if you have cracks over a 1/4 inch wide, industry prefers that the cracks be filled anyway. I mean, you know, we all know we're not with thin surface treatments. I mean, we put chip seals down and we put, you know, micro surfacing down, and we put a combination of the two down, which we call a cape seal. But if you can get the crack seal done in advance so traffic has time to get on it, you know, make sure it's smoothed out and those things, it's always better. But we always recommend crack fill, crack seal if there's cracks that are over a 1/4 inch wide before you do any type of preservation treatment.
Excellent. And just one more quick one. Any issues with cutting centerline corrugations?
We have not seen any issues in doing that. You know, we've had some down where they've done edge line corrugations. There's been a couple of projects in different states where they've actually cut some centerline corrugations. We have not seen any issues with that right now at all.
Excellent. Well, thank you very much, Pierre. Thank you very much, Monica. Appreciate your time here. And we'll keep an eye on the QA chat to see if anything else comes in.
Thank you.
With that, we were going to move on to a presentation from our folks in the MDOT Office of Aeronautics. We have Mike Trout, who's the director. We have Michael Carnarvon, who's the airport inspection and licensing supervisor. We have Zach Texan, who's GIS and Unmanned Aircraft System, UAS analyst and pilot. And we have Ken Bowers, who's the grant and UAS analyst and pilot as well. So they're going to be talking about driving aviation safety improvements at Michigan's airports via aerial data collection. Guys, take it away.
Hey, good morning, everyone. Thanks, Brad. Hope that everyone can hear me here. My name is Michael Carnarvon, and we're going to be talking about some cool, innovative ideas going on in the Aeronautics department. So when we talk about aerial data collection, we're basically talking about how we're utilizing drones and unmanned aerial systems. We're seeing an influx across really a lot of different industries on how people are utilizing this to, you know, make things safer or make things more safe, more efficient. We definitely found use in our department. So quick introduction and background. My name is Michael Carnarvon, and I'm going to be presenting with Zach Texan and Ken Bowers. We're really in aeronautics. We belong to different departments, but we cross-utilize a lot, and especially with this program that we've initiated using drones, we're finding more collaboration. So to set the scene and talk about just really quick before we get into details with the innovative stuff in UAVs, it's important to talk about how we conduct airport safety inspections. So for public use airports in the state of Michigan, whether or not they're privately owned or publicly owned by a municipality, they're mandated by state and federal regulation for inspections to occur. Typically they happen on a 3-year basis with our current staffing level. Public use basically means no prior permission required. So any pilot who just wants to fly into an airport does not have to contact the owner for permission. We're talking about 230 to 235 airports in the state of Michigan that are public use, all the way ranging from turf runways to airports like Ann Arbor. Not as big as Detroit Metros and Grand Rapids because the FAA takes care of those ones. But some of these turf runways occurred or are created in people's backyards, basically. So we're dealing with airports like those all the way to airports like Ann Arbor that receive hundreds of thousands of dollars every year by the FAA. So there's a clear dichotomy of resources available to these airports, just something to keep in mind. So what's included in these inspections, we got airfield, pavement, and turf. As we said, we have airfield signage that we look at, paint markings, lighting, navigational equipment, wind direction indicators, etc. And airport approach surfaces, which is what we're going to talk about mostly here. So to set the scene of what we're talking about and utilizing UAVs, we're talking about approach surfaces. Basically, imagine a three-dimensional imaginary plane beginning at the runway end that extends upward and outward to a specific height and distance above the runway elevation. So direct your attention to the picture that I have there. It's basically a trapezoidal shape, and it exists to let airport management and really the general public that have property underlying airport approach surfaces to not allow anything to get created underneath it, or to let trees, natural growth, or terrain from extending into navigable airspace. So the logic really follows. If you have an aircraft flying in, you basically don't want to hit anything. So if you see that bottom right portion, you see 20-to-1 and 34-to-1. It basically refers to, if you remember from math class, rise over run. For example, every 1 foot up, you go X amount of feet over. These are measured the opposite way. So we see that 20-to-1, that's 20 feet horizontal. For every 20 feet horizontally, the slope increases by 1 foot upwards. So the dimensions of the slope, they vary based on, the design aircraft for the particular airport or runway. Obviously, you have smaller aircraft flying in the turf runways and larger jet propelled aircraft flying into bigger airports. And also, if the runway can accommodate, we say visual approaches or instrument approach operations. In a nutshell, that means instrument approach. I guess if I could, give you a parallel. Let's say you're driving in your car and you're basically not looking at the road at all. You're just looking at information that's available within the vehicle itself. Well, that's how some pilots fly, and it's a set of flight rules. So the obstruction clearance is more stringent, and therefore the slope will be more narrow, as you see that 34-to-1. So just some background. And the question is, what are the methods used to measure these approach surfaces? So when we go out and do these inspections, we traditionally use field tools such as, I'll show you in the next slide here. Traditional methods to measure, we use rangefinders, apnea levels or clinometers, and just some basic math in order to see, just get real general ideas on how tall an obstruction is, how high it might be in, X amount of years. Trees can typically grow from 3 to 5 feet per year. So really, it's definitely a cheap way, short of a survey, to measure these approach surfaces and basically measure the safety of that approach. Traditional data gathering, basically we can tell, it's a litmus test of, is there an obstruction? Is it in or out of the approach surface? And the picture that I have there is an example from an inspection report, where really the best we can do is draw a line and just point arrows or draw circles to where offending trees are. That's the approximate 20-to-1 surface. So we have been severely limited in these 3-year checks to determine, I guess, what exactly is going on in an airport's approach. What you see here is, it's really multiple rows of trees, but just from a picture, and I can tell you from being on the ground, it's very difficult to tell sometimes, and we're looking at obstructions that are hundreds to even thousands of feet away. So it's not all encompassing information, basically multiple rows of trees. We can't really report exact locations. But with the rangefinder, it does a decent job, but still it's not the greatest. Also, you couple in human factors such as, navigating around difficult terrain on the airfield, inaccuracy of the basic equipment, or if you mess up the numbers, if the math is wrong, then your slope clearance or obstruction clearance on the slope can be off. Weather, you really couple all that stuff in, and it's basically a primitive way to measure, but like I said, you can tell if something is in or out. Now, talking about the resources available to airports, the airports that receive federal money, in other words, hundreds of thousands of dollars per year, they're required to get a survey as part of updating some of their design documentation for the airport, and those can cost dozens of thousands of dollars. But it doesn't account for all these other airports that we have, these turf runways and airports that don't receive federal money, that we would like to have the same value of obstruction gathering data. So with all of that in mind, I'll pass it off to Zach Texan, who will talk about the UAS program.
Awesome, thank you, Michael. I started up here. Okay. So hi everyone, I'm Zach Texan with the Office of Aeronautics, and I'll be going over how we utilize UAS, also known as unmanned aerial systems, but more commonly referred to as drones, within our office to enhance our airport inspections that Michael just talked about through what we call runway obstruction surveys. Just very briefly, we do this by taking photos of the approach areas at all the public use airports with drones, and then reconstruct a three-dimensional model of that survey area for analysis. So going into the survey methodology, we inspect various state and federal runway approach regulations. Again, Michael just went over those. So the photo on the left there kind of showcases a 2D view of several different approaches, and this provides guidance to our on-site survey team looking at photos like that. So the actual survey itself on site can be broken down into three main components, the first being ground control points. And for those of you who are unfamiliar with photogrammetry or any of or what ground control points are, they're basically recorded latitude, longitude, and elevation points within the survey area that will be used to correct the position of our final model. So we use a high accuracy GPS recording instrument for this purpose, which I'll show you a picture of that in the following slide here. The photo on the right is actually a screenshot from one of our on-site surveys, and they're kind of difficult to see, but the blue crosses are actually the locations of each ground control point for that particular survey. After the ground control points are collected, then we can move into our drone flight itself. The drone follows a predetermined flight grid and takes photos with the correct overlap automatically. The flight itself is actually pretty much autonomous. We program the drone before it takes off, and then it will basically do the rest. Each survey has a minimum of 2 people on it. We have the pilot in command, who does have the ability to override the drone in any sort of emergency situation, or if there were to be any sort of issue during the flight. There is also a visual observer present who keeps eyes on the drone at all times. I do want to note that we follow all Part 107 guidelines when flying, and Part 107 is the FAA's rules and regulations with regards to commercial drone flights. The last step to our on-site survey is initial data verification, where we will basically make sure that there aren't any major issues with the data we collected before we pack everything up and head home. So this is just a few photos of our on-site survey. So on the right there is our ground control point collection with a couple of high accuracy GPSs. In the center there is 2 visual observers and a pilot in command trying to find the drone or watch the drone amongst the clouds there. And that's because if you look at the top left photo, in the center of that large cloud, there's a very small dot, and that's actually what the drone looks like for the majority of the flight. We fly just under 400 feet above ground level, and sometimes the drone is several thousand feet away from the takeoff point. So it gets very small very quickly. And then the bottom left photo is me in the back of our van doing some initial data verification. So once the actual survey, on-site portion of the survey is complete, we can bring all that data back into the office and create a three-dimensional model from all those collected photos using software called Pix4D Mapper. And because of all of the ground control points that we collected on site, the majority of our models have been seeing accuracies within 3 inches. It does depend on the topography of the survey area. Some are less accurate than that and some are more accurate, but 3 inches is a good average for what we've collected thus far. Once the model is created, then we can import a 3D model of the approach regulations and kind of visualize the penetrations and do further analysis. Just going over the pictures real quick, the top 2 pictures are just the point cloud that gets generated. The top left is a heat map of elevation, so the red are the tallest trees in the entire survey area. And then the top right photo is just the RGB values of the point cloud, so it's obviously a more realistic looking model. The bottom right photo is what we do the majority of our analysis on, and that is with the approach slope imported in, and you can very clearly see that at this particular airport there are about 10 to 15 trees and bushes that penetrate that particular approach slope, and those need to be cleared in order to for that airport to come into compliance. So this is just a short clip of kind of what the point cloud looks like. I just want to give you guys a better idea of kind of what the three-dimensional point cloud looks like. It's hard to visualize it from a 2D image. So from this point cloud, we're able to provide airport managers and sponsors with detailed latitude and longitude data as well as elevation data. So we really want to provide them with a comprehensive view of their approaches and make sure that if they're going to go out and clear trees, that they clear all the correct trees, or if there are other obstructions that they know about those obstructions. So that was really just a quick overview of our runway obstruction surveys utilizing drones. I do want to wrap up my portion with some results of some of our work. So this is kind of an example of a successful tree clearing project at Romeo State Airport. And Romeo State Airport is a state-owned airport, so we were able to kind of go through the entire process for this one. On the left there is a picture of our initial survey that we did back in fall of 2019. It turns out after we did all the analysis that the majority of the trees in the center of that photo actually penetrated various approach regulations. So throughout 2020, we contacted a tree clearing company, provided them with the location data that we found for the penetrating trees, and they were able to go out and clear those trees. So we went back out then in the fall of 2020 after the tree clearing project, and were able to verify that all of those trees were clear, and the airport is now in compliance, and as a result, much safer. So that concludes my portion. I'm going to hand it over to Ken Bowers now, who will be talking about how other areas of MDOT have also been using UAS.
All right, thanks, Zach. Let me get this going here. All right, so as Zach said, I'm Ken Bowers. I'm an FAA Part 107 remote pilot for MDOT's Office of Aeronautics. I'm just going to go over briefly some of our other support that we've done using UAS within MDOT, other agencies. As we got our UAS program off the ground, and before we really got into our runway survey flights, we started assisting a few other agencies within MDOT with various projects. One of the first projects I was a part of was with a UAS or drone along US 131 north of Grand Rapids to capture images of construction. And let me start this video here so you can see those photos. And we did that with MDOT's photography team. As you can see in the slideshow, this was a unique view of the construction process and gave a perspective as to how large the operation really was and where the project was as far as progress. This also gave the MDOT photography team the chance to capture video and pictures of the movable barrier being shifted and the effect that it had on traffic, which they had not really gotten a chance to get that angle of that barrier before. We've also conducted numerous ITS or Intelligent Transportation System field reviews using UAS. The first one was conducted along, again, US 131 from about 6 mile to 10 mile road, where we shot 4 locations for either CCTV or weather data collection poles. The flight was so beneficial that the engineers actually called us back out to do 4 additional sites later on. And actually last summer we spent a day going around the Grand Region from South Haven up US 130, I'm sorry, up 31, US 31, and over to Big Rapids at US 131, and back down to Ionia and Portland. I think we did 9 additional locations that day along various M routes. In addition to that, we also want to assist anyone looking to obtain a license so that they can potentially fly for their own department. We've held 3 classes at our Office of Aeronautics facility where we cover all the pertinent material for FAA Part 107 remote pilot testing, and we provide a good amount of hands-on practical application with various types of UAS devices. I believe that's something we will continue as long as the interest is there from other areas, and of course once the COVID restrictions open up a bit. So I did want to show briefly what we're looking at in terms of when we go fly those ITS CCTV locations. These pictures here are shown part of the latest ITS flight along US 31 in Grand Haven I did a few weeks ago. Both sets of pictures are different locations, but also at different height requirements depending on visibility, either 35 or 40 feet or 80 feet. So you can see the top pictures are the lower altitude and the bottom pictures are the 80-foot altitude. So sometimes it does not change the visibility of the route and the traffic. And in that case, the engineers can utilize a shorter pole to save costs. However, these are great examples of instances where the height of the camera would drastically change the visibility because of trees in the median or a curvature in the road. And you don't really get that. You can obviously, you know, the curvature is there, but you don't get that depth until you're actually up at that height. There have been many instances where the engineer had planned for a location, but once we get up in that spot, it was too restrictive and better off 5, 10, 15, 20 feet in various directions. So utilizing UAS for these ITS field locations is also safer, quicker than the traditional systems, removing the need for scheduling a boom truck or utilizing a handheld pole with a camera on it, which is very uncontrollable and dangerous in any wind. These are basic straight up and down flights, but the pre-flight planning remains the same for every flight that we do. We do have to look out for power lines, trees, communication lines, so it's important to have that visual observer, as Zach mentioned, in addition to the pilot command, because their focus is on the controls and the camera of the UAS so that the engineers can see what we're looking at. We utilize the median as much as possible, and with boom truck, the traffic probably most likely would have been blocked in one lane. And with the wind that we had that day, although the drone could take it, that handheld pole would have been a liability in that small median with traffic on either side. So the feedback we get from these flights has been nothing but positive from the engineers and the contractors that we've flown for. That's really all I had. It's a brief overview of the support that we've provided and can provide going forward. If there are any questions for any of the information that we've covered, we'd be happy to try and answer them. Thank you.
Excellent. Thanks, Michael, Zach, and Ken for that. It was interesting for me. I kind of thought about the EMILY in the same vein that let's put the technology in people's hands and let's figure out how many different ways we can use it. So I don't see any questions right now in the chat. So again, we're about 10 minutes over. I appreciate everybody's patience here, but this is some great information. Move on to the last one, and again, we'll keep an eye on the Q&A pod. So with that, the next presentation will be by Ahmad Azmuda, maintenance engineer at MDOT's Macomb TSC in the Metro region, and Joe Vitale, the vice president of operations for Cimarron Road Division. They're going to be talking about cold pourable pavement repair.
Thank you, Brad, and thank you for the opportunity to be here. Good morning, everyone. My name is Ahmad Azmude. Today, along with Joe Vitale, Vice President of Operations for Cimarron Road Division, we will be presenting cold pourable pavement repair project. I will start with the introduction to provide a brief information about pavement history and attributing factors for selecting cold pour repair. Joe will then take over and explain the product, installation, Gratiot Avenue project, and show you lots of photos. I will be back to talk about the cost comparison with alternative products and saving we had from using cold pourable pavement repair. I will then go over a brief conclusion and we will wrap up our presentation and answer any question you may have. Pavement history for a state trunk line M3 known as Gratiot Avenue. The section of the Gratiot Avenue where we perform cold pourable pavement repair was constructed in mid-50s. Capital Preventive Maintenance or CPM project was done in 1992. No major construction has been done in this section of the Gratiot for about 29 years, except sealing cracks and joints, and of course, lots of pothole patching. Attributing factors for selecting cold pourable pavement repair. Due to the very poor pavement condition, there were challenges concerning manpower and equipment for the maintenance crews to keep up with pothole patching. Therefore, a short-term heavy maintenance project was necessary to hold the pavement together until we do a reconstruction project. Typical heavy maintenance project that we had done in the past as a short-term fix included hot mix asphalt, detail 7, and hot mastic. I will go over these repairs method later in the presentation. We were familiar with cold pour pavement repair because we had done a couple pilot projects in Macomb County, small pilot on M59 in 2018, larger scale pilot on M53 in 2019. Pilot repairs were holding up. We were particularly interested in cold pour repair because cold pour liquid did not contain volatile organic compounds or VOCs, comparing to hot mix asphalt detail 7 and hot mastic. We could not determine the comparative cost of the cold pourable pavement repair through the pilot projects because the repairs were done with assistance from our maintenance crews and the work was not comparatively bad. We felt confident selecting cold pourable pavement repair to take care of surface maintenance issues. However, we still needed the answer for the following question. Will cold pourable pavement repair still perform on a very poor pavement condition like Gratiot Avenue? Will the cost of the repair be competitive compared to HMA detail 7 and hot mastic? And finally, will this repair reduce the cost of routine pothole patching budget? We will answer all these questions and much more. Stay tuned. Now I will hand over the presentation to Joe Vitale from Cimarron.
Thank you, Ahmad. My name is Joe Vitale. Oh, there's a slide. Thank you. I am the VP for Operations for Cimarron, as Ahmad mentioned. I want to thank everybody for the opportunity to be here today. So what is the cold pourable pavement repair? Cold pourable pavement repair is a water-based, polymer-blended asphalt emulsion that is combined with an aggregate and an activating material that, once mixed, creates a flexible but durable road repair. Our product contains no VOCs, is self-leveling, and can be applied in a wide range of temperatures. For purposes of this presentation, the pictures that are part of this PowerPoint leading up to the M3 Gratiot Spotlight are for demonstration purposes only. It is our hope these pictures will give the audience a clearer understanding of how the cold pour product is installed, what it looks like during installation, and how the product looks once fully cured. This is a picture of our machine that we use. It's our tow behind cold pour machine and is comprised of a 250-gallon tote mount deck, a 1,500-pound aggregate hopper, several internal augers that mix the material, and there's a swing arm off the back of the machine that places the product. This picture illustrates how our cold pour product looks when being placed on the road. As you can see, the dispensed product is a liquid slurry type of consistency after mixing, then poured. This is how our product looks after it has been squeegeed evenly across the repair with some overbanding. The idea is to completely seal out the edges of the failed area. This is how our product looks once it is fully cured, roughly 30 to 60 minutes after it has been placed. At this point, we are open to traffic. Reloading of material occurs in less than 30 minutes and we are back to work. 250-gallon totes of liquid are swapped out and the aggregate hopper is refilled, as you can see the Cimarron crew doing here. So what are some ideal uses or areas for this material? Our cold pour material performs well on both concrete and asphalt roads and is a cost-effective repair for many types of pavement distresses, including concrete roads with transverse and longitudinal joint failures, asphalt roads with lane line separation issues, again, asphalt roads with centerline deterioration, and other various types of pavement failures. In the summer of 2020, Cimarron was awarded the contract to perform both transverse and longitudinal joint repairs on M3 Gratiot, from Common Road to 14 Mile Road, with our cold pourable pavement repair. The scope of the project was to high pressure blow out, prime, and place our material on all transverse, longitudinal, and adjacent pothole areas over a 7-lane mile working area. To minimize disruption to the motoring public, work was conducted at night from 7 p.m. to 5 a.m. The following 2 slides will represent some of the existing roadway conditions prior to the start of the project. As you can tell, the road was in very poor condition. The following 2 slides are pictures of the Cimarron crew working during the project and illustrate some of the conditions present on the roadway. 2 lanes remained open to traffic during the entire project with intermittent turnaround closures only in work zones, with the entire road open fully to traffic by 5 a.m. each day. The next four slides will represent some before and after pictures of several areas during the project. As you can see from the pics, the task of the cold pour material was to seal up the failing areas and minimize continued failure. One question that is always asked is, how does this material hold up or perform? The following three slides are pictures that were taken in February 2021, so only a short period after the work. But they illustrate how the material looks as we come near the end of the 2021 winter season. So far, in my opinion, the material is performing well. We at Cimarron believe the cold pour material offers many advantages over other methods currently being used. These advantages include next to no downtime or waiting around for materials to heat up, improving production. Our product, as mentioned prior, contains no VOCs, which is an environmentally friendly alternative. Product placement can be deeper than 2 inches in a single lift. We have material variability on demand based on smaller, larger areas, meaning we can pour our material more liquidy or stiffer based on road conditions. Our machine has a wide range of motion, so we can make various repairs concurrently, leading to much more production. And finally, we offer very competitive pricing and believe we can be another tool for road agencies to stretch their maintenance preservation dollars. One item of note, Cimarron is currently working with Rob Green and Andy Bennett from the MDOT Preventative Maintenance Department, as the cold pour material is an emerging technology. Now I will hand the presentation back over to Ahmad for the final few slides.
Thank you, Joe. We thought the best way to determine the cost effectiveness and production rate of the cold pour pavement repair was that we compare it with the repair method that we had considered to use for Gratiot Avenue. Hot mix asphalt, detail 7, is more labor-intensive repair. It involves removing all loose deteriorated asphalt or concrete by milling or jackhammering, cleaning joints or potholes, applying an application of tack coat, and placing compacted hot mix asphalt in prepared clean surfaces. With temperature of asphalt mixture ranging from 250 degrees to 350 degrees Fahrenheit. Mastic is a hot applied pourable aggregate filled with polymer modified asphalt. The joints or potholes are cleaned and then filled with hot mastic with temperature ranging from 375 to 410 degrees Fahrenheit. Joe did a good job explaining cold pour. I don't have much to add. As the table illustrates, cold pour pavement repair was much more competitive in cost and had much higher production rate. EMILY.to always welcome high production rate projects to minimize mobility impact and user delay costs during construction closure. We thought the best, the surface maintenance or pothole patching is the second costly maintenance activity after winter maintenance. Typically 20 to 25% of our total maintenance budget goes into repairing potholes. As the table illustrates, in the first quarter of this fiscal year, October to December, the pothole patching cost for this section of Gratiot Avenue was reduced by more than $16,000 or 93%, comparing to the first quarter of last year. Just a clarification, this savings only representing for about 14 lane miles where we did the repair. To put this in perspective, we maintain about 900 lane miles of state trunk lines in Macomb County alone. With this rate and based on 5 years average cost, we expect to save about $60,000 in this fiscal year alone. Any cost saving from maintenance funds help to take care of deferred maintenance needs, such as fixing broken drainage structures, curb and gutters, culverts, or roadside improvement like mowing and letter pickup. Conclusion. Holding up. It's a good test for any repairs going through a winter season. This winter, particularly the month of February, was harsh. Significant temperature changes along with freeze-thaw cycle are tough on pavement structure. Joe showed lots of photos. A picture worth 1,000 words. Repairs appear to be holding up with no noticeable distresses. In previous slide, we show you the cold pour repair was cost-effective, had decent production rate, reduced our maintenance costs, and result in about 93% cost saving. I'm pleased to announce that after checking with our damage claim coordinator, no damage claim have been submitted for Gratiot Avenue after the repair completed to the state. Environmentally more friendly due to no VOCs. In conclusion, we're hoping that we have earned our customer satisfaction. The next two slides are the contact information for me and Simon on the staff. Next, and basically, you're done. Thank you for your time today.
Thanks, Joe. Thanks, Ahmad. There is one question here quickly is what is the optimal temp to apply cold pour? Is there any disadvantages to pouring during cold temperatures?
It's a good question. I would look at it in terms of optimal temperature for our crew would certainly be somewhere, in the 60 to 80 degree range. Nice working conditions out there, but no, to answer the question. The only caveat to that would be in colder temperatures, we might add a little bit more of the activating material to help that material cure within that 30 to 60 minute time frame and get that road open to traffic. So no.
Great. And one more question came in. It says, can there be media added to the cold pour? I'm assuming like an aggregate or binder or fibers or something like that.
Well, there already is an aggregate that is added, and that's something that R&D is always looking at to help with performance in terms of a good homogeneous blend of material aggregate throughout, but certainly something we consider going forward from the R&D side of things is, are there things that we can add to this cold pour to certainly enhance things or make the product improvement better in performance?
Excellent. Thanks again, folks. I think with that, we can start to wrap up. This was another great round of presentations. I'm glad that we've expanded this to the full STIC, and now we have industry and all of our other transportation partners here. Just want to call back a couple of the things that are in the Q&A. There's a link to our STIC's webpage, as well as a note from Carol Aldrich, who heads up our research area for MDOT, noting that we do have a $100,000 grant essentially that comes through the STIC for any of us to be able to kind of further a lot of the innovations and really get more to the implementation side on the innovations that we talk about. And they don't have to be specific to everyday accounts. So work through your industry or agency representation on the council for that, and we can have more discussion. With that, thanks again for sticking with us here. I'd like to turn it over now to Ted Birch from the Federal Highway Administration, Michigan Division Office.
Thanks, Brad. So, yeah, we've heard about some great stuff this morning. We've heard about things that have been developed by MDOT, by industry. We've heard things about some technologies that we've adopted from other states. Some technologies that apparently we've even saved or stolen from the life-saving industry. So all these things are technologies that help us do their job better, safer, improve how we do business, make things more efficient, longer lasting, which is the whole intent of Everyday Counts and the STIC initiative. So I want to say thank you to everybody who participated today, particularly our presenters. We had a good wide range of topics and presenters. I hope it gives you a flavor of some of the good things that are going on in Michigan. Again, I echo Brad. Check out that link to the Michigan STIC website on MDOT's website. It's in the chat pod. There's a lot of good information there, as well as I believe there's a listing of all the STIC members. Tony at the beginning mentioned that we've added quite a few new members this year. So a lot of people to reach out, again, across the state, across the industries. And the last thing I'd like to do is invite anybody that's got an idea on something that you would like to present, something that you're developing, you've developed, something you think is innovative that could be used by others across the state, to present them at our next STIC highlights session. If you've got an idea, please reach out to your industry or your agency representative on the Michigan STIC, or you can reach out to MDOT directly. So we're always looking for good ideas and things to promote and spread the good word of all the stuff that's going on across the state. So with that, I would, on behalf of the Michigan STIC, thank you once again for participating, and we look forward to seeing you again for the next STIC highlight session.
Thanks everybody for your time. Thanks presenters. Take care and we'll see you back here this fall.